Good morning, myself Anala from GPC Kunimra. Today we will talk about error, their types and measurements. First, what is an error? Some error they are due to human, like for example we are not using the equipment or apparatus correctly, so this may cause an error. Let us look at some example. First example is Professor Measure is trying to measure the length of the piece of the wood. So discuss what he is doing wrong. How many mistakes you can find? So let us find the mistakes in the measurement. These are all human error. Like first mistake he is doing that he is not measuring from the 0, he is measuring from 100. So this is first mistake he is doing. Second mistake is he is doing 90, he is writing 95.4, which is wrong number. This is not correct number. Third, mm is the wrong unit because it is in centimeter. He should write 95.4 centimeter, but 95.4 is also wrong number. Fourth error he is doing in measuring is he had handheld object. This object is handheld, so there may be possibility of wobbling. So this may cause an error. Next human error is the gap between the object and the ruler. This gap also create an error which comes under human error. Next error is the end of the object. This end is not at the end or the starting point of the ruler. I is not at the end of the object, that is parallax error. He is not he is on the wrong side of the ruler to see the scale. So all these are the 8 types of mistake he is doing. These come under all the human error. So second example we can take for the human error is the reading the scale. If we want to read a scale at this point, we should be at this point, not at this and not at this, because these type of error they are called parallax error. This is very important. This error is called parallax error. So if we want to measure at this point, so this is the best position of the eye. These two position will cause an error in reading, because if we are here, then we will read most probably these values. If we are here, then we will read these values, not this. So to read this value we have to have at this point. So this type of error is called parallax error. If we change our eye from 2 to 1 or 3. So when the anomalous results they will come, when you are doing your practical work, you may get an odd or inconsistent or anomalous reading. This result may be due to simple mistake in reading a scale. So best way to identify an anomalous result is to draw a graph. Like we draw the graph here. So all these data points, this and this, these all are in same line, but this is different from this line. So this is our anomalous result. So here is some mistake in doing this data points, in taking this reading. So we have to recheck about this point, what error we are doing in taking this reading. So now we come to the theoretical definition of error. So if we are making a physical measurement, that is if we are measuring a physical quantity, so the measurement upon the physical quantity is called physical measurement. there is always an error involved in the measurement of the physical quantity. This error is denoted by the symbol delta, and it is followed by the variable which we are used to measure. Like if we are measuring the volume, then the error in the volume is delta V. So main point here in this slide is that error is always there when we are measuring a physical quantity. So error is noted by delta V. Like if we want to measure the error in volume, so it is noted by delta V. Next we come to the definition of error. A simple way of looking at the error is as the difference between true value and approximate value. Approximate value means which we are measuring. So error is noted by E is equal to true value minus approximate value. Approximate value means measured value which we are measuring in the physical quantity. So error is true value minus approximate value or measured value. Here we take an example for the error analysis. Here the statement is find the truncation error for at x is equal to e raised to power x if the first three terms in the expansion are retained. So we know x is equal to e raised to power x, or maybe capital X is equal to e raised to power x. Its expansion is e raised to power x expansion is 1 plus x square by 2 factorial plus x cube by 3 factorial and up to so on. So we have to find the truncation error if the first three terms of the expansion are retained. So error is equal to true value minus approximate value or measured value. True value is its expansion. Its expansion is this much, 1 plus x square by 2 factorial plus x cube by 3 factorial plus x4 by 4 factorial up to so on, minus if we are taking three terms, first, second and third, these three terms. So these all are three terms. If we minus these two, so error, that is truncation error, is equal to x cube by 3 factorial, x4 by 4 factorial, x5 by 5 factorial and so on. So this is error. This is truncation error in the expansion of e raised to power x if we want to take only three terms in the measurement. Next we come to the next point, that is types of error. There are different types of error, you know all these. First error is gross error, or we may call it as human error. Second type is random error. Third type is systematic error. All these three, that is gross error or human error, random error and systematic error, all these three come under the type of static error. And next, fourth type is constant error. Fifth type is absolute error. Sixth one is relative error, and seventh one is percentage error. We will study all these in detail. Gross or human error, random and systematic, they come under the category of static error. Rest error, they are calculated from these, that is constant error, absolute error, relative error and percentage error. Now we study detail of these type of errors. First one is gross error, that is human error. As clear from its name that it is caused by the human readings, human mistake in reading or measurement. So gross error, it is caused by the human mistake in reading or using instrument. So it is maybe due to reading or maybe using instrument, and it is mainly due to human mistake, that is human is doing wrong way, using wrong way to measure a thing. It may also occur due to incorrect adjustment of the instrument and computational mistakes. Next reason about its error is it cannot be treated mathematically. We have to treat it manually, that if the human is taking reading in the wrong way, we have to correct it manually. It cannot be corrected mathematically. Gross error cannot eliminate, it cannot be eliminated but can be minimized. So we have to take care about each and everything, that is instrument is adjusted properly, etc. Next, its reason is improper use of an instrument. If we are not using instrument properly, then gross error may happen. This error can be minimized by taking proper care in reading and recording measurement parameter. Next reason for the gross error is that in general, indicating instrument change ambient conditions to some extent when connected into a complete circuit. So, instrument may change something like ammeter and voltmeter if we connect in the complete circuit. Next, the gross error reason is that several reading at at least 3 readings must be taken to minimize the effect of ambient condition changes. So, if we want to correct this type of error, we have to take at least 3 readings to minimize this type of error. So, if we are doing in the wrong way for the first reading, maybe we can correct for the second. So, we can take the average of 3 readings, or we can correct the first reading if we are taking in the wrong way. Next type of error is systematic error. As clear from its name is, systematic means system means instrument. It is purely due to instrument. So, it is due to shortcoming of the instrument such as defective or worn parts, aging or effects of environment on the instrument. So, all these are factors for the shortcoming of the instrument. If we are using the instrument which is not reading properly, then this type of error comes under the systematic error. Systematic means system means instrument. So, it is because of instrument, purely due to instrument. Next point is, in general, systematic error can be divided into 2 parts. First one is static and second part is dynamic error. Static error, it is caused by the limitations of measuring device or the physical laws governing its behavior. Dynamic, it is caused by the instrument not responding very fast enough to follow the changes in the measured variable. For example, if the current is changing very frequently, but our instrument is not responding too much, so this type of error is called dynamic error. That is, the system is very fast, but our system is not responding too fast. So, this type of error is called dynamic error. I hope it is clear to everybody, systematic error, and this error is very important error in understanding research point of view. And systematic error is further divided into 3 parts. First one is instrumental error, second type is environmental error, third type is observational error. So, from the 3 points, it may further clear that systematic error may be due to system, may be due to environmental effect. If the environment changes our system, so it may be due to environmental effect. Third, it may be due to observational error. We are observing in the wrong way, so this may also cause an systematic error. Now, we will study detail all these type of error, that is instrumental error, environmental error and observational error. First type is instrumental error. It is inherent while measuring instrument because of their mechanical structure. We will study detail all this. This error can be avoided by selecting a suitable instrument for the particular measurement application. Second, it can be avoided by applying correction factor by determining instrumental error. If we know instrumental error, then we can always apply some correction factor from the, like if we take a test in the class. So if you copy from the another student, I may subtract 10 marks from each of the students. So this is correction factor. Third, we can eliminate this error is to calibrate the instrument against the standard. So we can calibrate the instrument. So further this error can be minimized. Next, second type is environmental error. Environmental error, this name is clear that it is due to environment. For example, we want to do an experiment of the magnet. So here we are doing some experiment. Here is some magnet, another magnet which is disturbing our system, our instrument. So this is environmental error. This is due to environment. Environmental error due to external condition affecting the measurement, including surrounding area condition such as temperature, humidity or magnet or baromagnet pressure, etc. To avoid this error, use air conditioner because it lessens the humidity. Second, sealing certain component in the instrument. Third, use magnet shield. So magnetic field should not affect our system, our instrument. So we can use magnetic shield to avoid environmental error. Third type is observational error. It is due to observer. Observer means you are taking the readings. So it is purely due to observation, observer which is taking the reading. So the most common which we have already studied is parallax error and estimation error while reading the scale. For example, an observer who tend to hold his hand too far to the left while reading the position of the needle on the scale. So it may cause an error. It is purely parallax error. So this type is called observational error. It is due to observer, that is the person who is taking the reading. Next type, static error, is random error. Random error is due to unknown reasons, unknown causes. It occurs when all the systematic error has accounted. It is due to accumulation of small effect. It requires very high degree of accuracy. That is, random error is always there. It can be avoided by increasing the number of reading. Second, it can be avoided to use a statistical means to obtain the best approximation of the true value. If you are doing, here we take an example of the random error. So if you are doing some experiment like Werner caliper, so your teacher suggests to take at least 3 readings for each experiment. So these 3 readings are, so he or she suggests you to take 3 readings at least. This is due to random error. So random error can be removed by taking increasing number of readings. So if we increase the number of readings, then we can take the average of all these readings to reduce the random error. Random error cannot be 0, it is always there, but it can be minimized by increasing the number of readings. Now we study in detail about systematic and random error, because these two are very important error. So I thought that I should add some more material about these two type of error. First is systematic error. Systematic error is caused by any factors that systematically affect measurement of the variable across the sample. For instance, if there is loud traffic going by just outside of the classroom where students are taking a test, this noise is liable to affect all the children's scores. In this case, the systematic lowering them. So systematic error may be positive, may be negative. For all the readings, it may be either positive or negative. Unlike random error, systematic errors tend to be either positive or negative. Because of this, systematic error is sometimes called bias in the measurement. This term is very important, biasing. So, if we are taking a measurement, if there is some bias, then this is purely systematic error. These error cause readings to be shifted one way from the true reading. It may be either in the positive way or in the negative way. Your results will be systematically wrong. So let us look some example for the systematic error. First example is, suppose you are measuring with a ruler. If the ruler is wrongly calibrated or it expands. So if the actual thing is this, but it measure here. So this is the systematic error. Then all the readings will be too low or too high, depending upon what type of error, either positive or negative. Second, you have already studied this parallax error. It also comes under the systematic error. So your eye should be at this point, not at this, not at here. So this gives rise to systematic error, that is parallax error. Third, this type is very important. A particular type of systematic error is zero error. It is in one experiment, that is vernier caliper. I think you have already done this experiment about the measurement of the volume for the with the help of vernier caliper. The error in the vernier caliper is zero error. Its name is zero error, it is not zero. It may be zero depending upon the instrument, but its name is zero error. Here are the some example of the zero error. First one is spring valence. We know over a period of time, this point not comes at 0 point, it shifted from 0. So this gives an error. This is called zero error. Over a period of time, the spring may weaken, so the pointer does not point to 0. So the pointer comes here, not here. So this may cause an error which come under the category of systematic error, and further if we want to subdivide, this is called zero error. That is, if the pointer or 0 is not matching with this 0, then this type of error is called zero error. Next example is, like we are going somewhere to buy a thing. We know if there is some 0.000, then the zero error is 0. But if there is already 0.02, 0.03 gram, then it may cause an error. This is called zero error. There is nothing on it, but it is not reading 0. So this error is called zero error. Next important example is, look at this ammeter. Here this the point of the starting needle is not at 0, so it may cause an error. This error is called 0 error. So we have to add this reading every time. And next example is look at this voltmeter. Here the 0 of the voltmeter is not the starting position of the needle, so it may cause an error. This is called 0 error again. Next example of 0 error is that, so this is an ammeter. Here this symbol shows an ammeter which is used to measure a current. So we can easily see that the needle is not at point 0, but the first thing is that it may be 0 error, it may be parallax error. So we should add the perpendicular point to take an reading. So for the measurement of this mirror is attached at this point, this mirror. If this needle is here the mirror reflection of this needle at this mirror. So if the mirror reflection and this needle they matches at one point, then parallax error is 0. So this error is purely 0 error, because the starting point of the needle is not matching with the 0. So this error is 0 error. Next is random error. It is caused by any factors that randomly affect the measurement of the variable or the physical quantity across the sample. Each person's mood may inflate or deflate their performance on any occasion. In a particular testing, some children may be in a good mood or other may be depressed. Mood may be artificially inflate the scores for some children or artificially deflate the score for the others. So depending upon, it is random error, it is due to unknown reason. A random error does not have consistent effects across the entire sample. If we could see all the random error in a distribution, then the sum would be 0, because the random error may be positive, may be negative. So some readings are in this side, some readings are in the opposite side. So the sum of all the things should be 0. The important property of the random error is that it adds variability to the data, but it does not affect the average performance for the group. Average performance remains as such, but for the data for each point it adds some value. We know this random error are not inherent to the measuring process. It is due to unknown reason. Frequently they are introduced by external reasons, external factor that cause a scattering of the measured data. When the scattering is distributed equally about the true value, the error can be mitigated somewhat by making multiple measurement or averaging the data. This thing is very important in random error. Random error, for the removal of random error, we have to increase the number of reading and taking the average of all the readings. Next, this is example of random error. This may be due to human error or faulty instrument or faulty technique. To reduce the error, we have to take the number of readings and then calculate the mean or the average. Next type of error is constant error. When the results of the observation are in error by same amount, the error is said to be a constant error. For example, if a scale of 15 centimeter, it actually measure 14.8 centimeter, then 15 minus 14.8, 0.2, then it is measuring 0.2 centimeter more in every observation. This type of error will be same in all measurement done by scale. So, constant error is always constant, it is in every reading. So, if the actual thing is 15 centimeter, but we are measuring 14.8, so there is some error. This error is called constant error. Next, rest three types are called absolute error, relative error